Good morning, Swans and Falcons, and welcome to Tuesday's maths lesson. Okay, today's date is the 2nd of March, and your learning intention for today is: can I calculate the area and perimeter of rectilinear shapes? Okay, so some warm-up questions for you. Pause the video, have a go at these, and then restart when you're ready to go through the answers together. Welcome back. Right, last week we were doing some work comparing miles and kilometres, and we found out that 5 miles is approximately 8 kilometres. So if we know that, how can we work out how many miles is 40 kilometres? So if we know that 5, get rid of that, 5 equals approximately 8, or remember it's that squiggly line, wasn't it, show approximately, and we know that we have 40 kilometres. In this case, we're looking at the relationship there between how many multiples of 8 we have in 40. That's times 5, isn't it? So then if we times this by 5, keep it in proportion, we know that 25 miles is approximately 40 kilometres. Okay, if n equals 12, so thinking back now to before half term in our algebra, if n equals 12, work out 5n minus 2. And we can substitute the n for the 12, the value 12, can't we? So remember, 5 followed by directly by the letter is multiply, so that will be 5 times 12 minus 2. And 5 times 12 equals 60. 60 minus 2 equals 58. Write 80% as a fraction. Okay, so going a little bit further back in our learning mind, and remember, fraction is out of 50. Percentage is out of 100, sorry, not out of 50. Oh, it's been a long week. Percentage is out of 100, so we can show that as a fraction as 80 over 100. Okay, so simplified, well, we can divide top and bottom by 10 to start off with, can't we? So that would be 8 tenths, but again I can still simplify that further, because a factor of 8 and 10 is 2, so if I divide top and bottom by 2, that will give me 4/5, and that is 80% in its simplest form. It might be that you knew that 1/5 was 20%, therefore 80%, which is four lots of 20%, is 4/5. Which of these numbers are prime? So what's a prime number again? Remind me what a prime number is. That's right, it's a number that's only divisible by itself and 1. Okay, so, and there is only one even prime number, because all other even numbers have 2 as a factor. So 2 is a prime number. 5 only has itself and 1. 7 only has itself and 1. 9 doesn't, because 3 is a factor of 9, isn't it? 3 times 3 is 9, it's a square number, and 26 being even will have 2 as a factor as well. So hopefully you got on okay with those, and if you didn't, hopefully just by going through it you've worked out where you went wrong. Okay, so going back to what we were looking at yesterday, we can count squares to work out the area of a shape, because when we're looking at the area, we're looking at the inside of a shape, aren't we? And we can if we think that each square is 1 centimetre squared, we could count all those squares to work out the area. However, sometimes if the shape gets quite big, it's quite time consuming, isn't it, counting squares? So what I want to be able to do is do it a more efficient way. And we looked at the end of last lesson about how actually if I count all those squares up, there would be 32 squares. And that's the same as doing 8 times 4. Okay. If we think back to our algebra days then, the area, if we say the area is A, equals L times W, so length times width. Remember, when we put the things together, we can do, it means times. So in other words, A equals 8 times 4, which equals 32 centimetres squared. Today we're also going to look at perimeter. So if I wanted to work out the perimeter of this shape, I need to think about what perimeter is first. And the clue that I always use to help me remember is the word rim. Look, can you see it? Word rim in perimeter. Okay, And to me, the rim of something is the outside of it, the edge of it. So I need to work out what the total length of the edge is. And I know with oblongs that opposite sides are equal lengths. If this side is 8 centimetres, so is this. If this side's 4, then the opposite side must be 4 centimetres. Okay, so I could add all those numbers up to get my perimeter. But there's a more efficient way of doing it. So if we say that perimeter equals P equals, there's two ways of writing it. So we've got 2 lots of L, and we've also got 2 lots of W, the width. I could give it any letter, but I always like to give it a letter that kind of links with what I'm doing. But I can also write it this way. So P equals 2 lots of L plus W. Okay, so depending on how your brain works, either of those is fine, and you'll get exactly the same answer. Let's check that out. So I'm going to move on to the next slide. If we remember our dimensions, so we had the length, which was equal to 8, and the width, which was equal to 4. And I've got my 2 formulas. So I've got my 2L plus 2W, and I've also got my 2 lots of L plus W. Okay? So if 2 lots of L, 2 lots of 8, I substitute my values in. 2 lots of 8 is 16, plus 2 lots of W, well, that's 4. 2 lots of 4 equals 8, so the total would be 24 centimetres. Okay. If I'm using this formula here, I've got, the first bit I need to do when I'm thinking about bib mass is my brackets, isn't it? So I've got 2 lots of 8 plus 4, which is 2 lots of 12. Okay, I can't write 2 and 12 next to it because it would look like 212. 2 lots of 12, which equals 24 centimetres. So can you see how I get the same answer no matter what formula I use there? Okay, how about this shape here then? Because it's not as straightforward, is it, as doing length times width. Excuse me. So this is a rectilinear shape, okay? It's made up of more than one rectangle. So I need to look at the lengths first, work out what the lengths are. I can use a square to help me. So 1, 2, 3, 4, 5. So I've got 5. I've got going down 1, 2, 3 going down. 1 that way. 1, 2, 3, 4, and then a 2. Okay, so for perimeter, I'm adding up all of the lengths of the sides. So I have 4 plus 1 is 5, plus 5 is 10. I know 3 and 2 is another 5, so that's 15, plus 1 is 16. So my perimeter equals 16 centimetres. But what about area? It's not as straightforward as just multiplying length by width, is it? So I need to divide my rectilinear shape up into 2 rectangles, okay? And there's 2 ways of doing it. I could draw a line along here, and that gives me 1 rectangle and another rectangle. Or I could have done my line down here and had that rectangle versus that rectangle. It doesn't matter, it should give me the same answer. So for this one, it's a square that's 1 by 1. So that's going to be 1 times 1 is 1 centimetre squared. And then this oblong or rectangle here is, don't get confused by the 3, is 2 centimetres by 5 centimetres. So 2 times 5 is 10, so that's 10 centimetres squared. Then I need to add the 2 together, which gives me 11 centimetres squared. Okay. So let's have a look at these two, because I didn't have those ones before. I had the squares, so actually here I could have gone, oh right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares to help me with my area, couldn't I? But if I don't have that, and I have to just rely on knowing the lengths, makes it a bit trickier for some of us, doesn't it? So remember, my formula is area equals length times width, perimeter equals 2 lots of length plus width. So those are the formula I can remember to help me. So area then, area for this one equals 7 times 3. I could have done 3 times 7 because it's commutative. I could have said the answer equals 21 centimetres squared. And then my perimeter, because I know opposite sides are equal length, so if that's 7, that must be 7, and if that's 3, that must be 3. So it's going to be 2 lots, 7 plus 3, which equals 2 times 10 equals 20 centimetres. Okay. This one here is the tricky one, isn't it? Because it's a rectilinear shape, so I'm going to have to split it into 2. I'm going to go down this way today. So I have now an oblong that is 3 by 2. And I have, oh, this is the tricky one. I don't know what the length of that side is. But I know that that is 7, and I know that that bit there is 3. So the rest of it, that's opposite to here, must be 4 centimetres. So you imagine I draw an imaginary line here. That's 3, that must be 3, and the whole thing is 7, so that bit there must be 4. So let's rub that out so we don't confuse ourselves. So now I have a shape here that's 3 by 2. So 2 times 3 is 6 centimetres squared. And I have a shape here that's 4 by 7. 4 sevens are 28 centimetres squared. Plus my 6. So 28, add the 2 together. 28 plus 6 equals 34 centimetres squared. And for the perimeter, I need to add up all the lengths. But I've got the same problem as I had here. I don't know what the length of that is. But if I know that from there to there is 7, and I know that that part of it is 2, what's that missing length going to be? That's right, it's 5. So that's 5 centimetres. Then for my perimeter, now I need to add up all of those lengths. I can't use this formula for this. I have to add up the individual lengths. 7 plus 7 plus 4 plus 5, and I'm going to tick them off to let me know that I've added them on, plus 3 plus 2. So 7 and 7 is 14, plus 4 is 18. Oh, I'm going to add on my 2 next because that will then take it to the next 10. So 28 centimetres. Okay. Now sometimes we have problems where we might know the area but we only know the length of one of the sides, okay? So if we're thinking about, if we put it into our formula, so we know that A equals length, which is 6, times the width. I didn't need to write in equals 24. 6 times something equals 24. So I should be able to work out, shouldn't I, if I know my division facts, what the width is. So if 6 times something is 24, well I know 6 times 4 is 24. Therefore, my width must be 4 centimetres. What about if it was this way round and I knew what the perimeter was, but I didn't know what the area was? Okay, well if I know that that length is 6, then that must be 6. And 2 6s are 12. So 12 plus something is 18. Well, I know that 12 plus 6 is 18. So those two lengths combined must be 6 centimetres. So if 2W equals 6 centimetres, what's 1W going to be? It's going to be half, isn't it? So each of those lengths is going to be 3 centimetres. And look at these two shapes here, okay? This shows that you can have two shapes of the same area with very different perimeters, okay? So we have, let's have a look at these shapes then. We have a shape that is 12 centimetres, if we assume one of those squares is 1 centimetre by 1 centimetre. Okay, and then we have another one that is 3. I've drawn this wrong. Can't get the staff these days. Bear with me. While oh, got my pen as well. Been a long week, which is so I now have. A shape that is. So the area, 12 times 1 or 1 times 12, is 12 centimetres squared. 3 times 4 is 12 centimetres squared. But their perimeters are very different. So we have this one, we have 2 lots of 12. So our formula for working out the perimeter of this one here would be P equals 2 times 12 plus 1. Okay, because our width is 1 and our length is 12. This one here, so this would then be 2 times 13, which equals 26 centimetres. Okay, whereas this one, we've got P equals 2 lots of 4 plus 3. So that'd be 2 times 7, which equals 14 centimetres. Can you see how different? So we can have 2 shapes with exactly the same area, very different perimeters. Okay, I appreciate that that is a lot to take on board in one lesson, but by all means go back and watch the video numerous times, pause it, have a go at a few questions, have a look at another bit, have a go at the worksheet. If you have problems, then please post on the blog, and we will try and help you as best we can. Anyway, good luck, and I look forward to seeing you tomorrow for the next lesson. And I think we might be moving on to the area of triangles tomorrow. See you tomorrow. Bye.